So from last two sessions, we have started to discuss about network fundamentals. The day one, CCNA introduction and Cisco certification tracks and training program levels, and day-wise schedule. Network fundamentals is started about what is network, networking, internetworking, and types of networks, like roles and responsibilities of network engineer, LAN and WAN, and basic requirements to form a network. In that, we have finished NIC and NIC types, media types, networking devices, and device function, like where we use switch and where we use access point, routers, and firewall. Like NIC is a interface card to form a network, has two addresses, which is MAC address, or we can call the physical address or hardware address. So MAC address 48 bits, represented in 12 hexadecimal number. So in NIC, 48-bit MAC address, first 24 bits. What we call in first 24 bits in IC?
Organizational unique identifier.
Yeah, OUI, Organization Unique Identifier, Manufacturer ID. Okay. And NIC types we have seen, like Ethernet, Fast Ethernet, and Gigabit Ethernet. So what is the speed of Fast Ethernet port?
100 Mbps.
100 Mbps. Gigabit Ethernet port speed?
1000 Mbps.
1000 Mbps.
So 1000 Mbps or 1 Gbps, right? Ethernet? Ethernet?
10 Mbps.
10 Mbps. So yeah. And have shown you like how to check your NIC card speed also. Both NIC and media, guided, unguided, wired, wireless, coaxial, twisted pair, optical fiber cable. Most commonly used twisted pair, like RJ11 and RJ45. RJ11 for telephone lines, RJ45 or local networks. In RJ45, again, you have different type of categories, Cat5, 5E, Cat6. In RJ45, we have straight cable, cross cable, and rollover cable. So where we use crossover cable?
For
Connect similar devices.
To connect
type of device.
Similar devices.
Similar type of devices, exactly. Same type of devices, cross cable. And where we use console cable, so straight cable.
To connect different types of devices.
Example?
PC to router.
Switch to PC to router.
Or PC to switch.
Yeah, perfect. Then where we use rollover cable?
Configure the router.
Router control parts.
Yes, configuration purpose, devices configuration purpose, we use rollover cable. Okay.
Balu, one doubt here. So you said that there's routers and firewall and PC are in the same devices, correct?
Yeah.
So in that case, PC to router will be cross cable.
Cross cable, yes.
Okay, the straight cable, it is only PC to server then.
PC to server also cross cable. In between, if you use switch, then PC to switch straight, switch to server straight. If we connect PC to server, server to firewall, firewall to PC, firewall to, these all are same devices, similar type of devices.
So all are cross cable only, because
Cross
here
cable.
some
Between, if we use any switches, then straight cable will come. So generally, we don't connect directly PC to server. Between we have the switches is there actually. Yeah.
Correct.
If you want to use it to connect directly, then you can use crossover cable. Okay. So next, yeah, please.
From a router to a firewall, it is straight cable, right?
Can router to firewall also crosswalk cable?
No, crosswalk cable only, because all these are on the same devices.
Then, okay. Okay, thank you.
Yeah. So media is done, and next networking devices. Now we know like where we use switches and where we use routers, right? So switch is a hardware device which centralizes connectivity communication by using wired connectivity devices within a LAN. Wireless access point is also a hardware device which centralizes communication between wireless and wired devices within a LAN. So wireless access point can support for what? Wired and wireless both within a LAN only. And what is router? Where we use routers? Anyone can you please answer?
To connect the other
Router.
network, sir.
To connect outside or do
Outside the network or other networks, to other networks.
Exactly. So router is a hardware device which enables communication between two or more different networks. Then what is firewall? Where we use firewall?
Firewall is used for the filtering the traffic based on our policies.
Even firewall is also a hardware device which controls unauthorized traffic based upon what are the policies we have implemented on firewall. Right. Good. So we have started about discussing logical address, which is IP address. So address, IP address is a identification purpose, device identification purpose, and IPv4 32 bits, and we discussed clearly yesterday how to convert from binary to decimal and decimal to binary. And IPv4 address ranges like 0.0.0.2, 255.255.255.255. Between we have 2 power 32 combinations, which is 4.3 billion IP addresses. Like all 4.3 billion IP addresses been classified into 5 classes ABC. So ABC classes IP addresses are reserved for what purpose? Class A, Class B, Class A, LAN, and WAN.
WAN,
Class D IP addresses are
multicasting,
multicast, and Class E,
R&D, research and development.
research and development. Okay. 128.1.1.1. So these IPs belongs to which class?
Class B.
It's a class B. Okay, before that, you tell me the ranges of classes. What is the class A range?
0 to 127,
0 to 127. Class B range?
128 to 191,
Class C?
192 to 3.
Perfect. So like we have 198.1.18.2.20. Which class IP address?
Class C.
Class C.
Is a class C, right? 224.23.1.8.
Class D.
Class D.
D.
So these IP addresses are reserved for multicasting, right? Yeah. So yesterday we clearly discussed like how to do the calculations, right? Ranges. Like is all ranges classifications is done based upon what?
PBT.
Priority bit. So class A priority bit is 0. Class B is 10. Class C 110. Class D 1110. And class E is what? 41. Means 0 means how many number of bits are reserved? 1 bit. 10 means what? 2 bits. 110 means what? 3 bits, right?
Yes.
Okay.
And
So up to here. Yeah, please.
Balu, what is loopback address?
I'll tell you that.
Balu, one more here. So when we're just normally studying on the Mac, one more thing I saw that ECI. What does that mean exactly?
ECI.
Sorry, EUI. External unique identifier करके गा रहे हैं.
Yes, in IPv6 we can get that EUI method.
अच्छा, okay. It is for
UI
IPv6.
UI 64. Yes.
US.
IPv6.
Okay. It is also similar part of MAC, or it is very different?
Yes, that is a MAC address actually.
Okay.
In IPv6 classes we'll discuss about that. No issues.
Okay. Okay.
So this is all about yesterday we have seen, and today let me continue with IPv4 address. So I'm asking to everyone, do you have any doubts regarding to the last two sessions? Yes, please. If you have any small doubt also you can ask it. No, you don't think so, it's a silly doubt, can I ask or not? No, you don't think so like that. If there's any doubts you can clarify here. So this is a training. So you can ask any freely. All right. So today also, which is very, very important logics we are going to discuss. So again, I'm requesting to everyone, so please be concentrated here. And if it's possible, try to make a running notes also. Device 1, device 2, device 3, 4, 5, 6 devices. All are interconnected with a RJ45 cable to switch. So here, 2 or more devices are interconnected. What we call this is? It's a network. Yeah.
Network.
Then what is networking? Networking means what?
Communication between two or more.
Communication.
Yeah, communication. Like to enable communication, we have to assign IP address, right? For these devices, we have to assign IP address. So which class IP address do you recommend? Class A, Class B, Class C, Class D, or Class E? Which class IP address we have to use for this network? Can we use Class E IP addresses?
No.
Can we use Class E? No, Class E is not possible because it's a R&D purpose. Class D we can use?
No.
Class D? No,
No.
it's a multicasting purpose, right? So we can make use only ABC classes, either A or B or C, right? So again, my question is from ABC, which class do you recommend? A or B or C?
A,
Why?
then
I mean,
same LAN. I mean,
why not B and why not C?
It is C.
Because class A has lot of
Networks. Class A has lot of networks. Class C has lot of possibility for devices and less number of networks.
Yeah. See, as a network engineer, that is very, very important task. We have to decide in real time which class IP address and where we have to use and these things actually. Yeah? So how to decide that means in a network, how many devices are interconnected here? In this diagram, how many devices are interconnected?
6.
A device in a network we call host. Device in a network we call what? Host. So here we have a 6 hosts are available, right? Host 1, host 2, host 3, like 6 hosts. So 2 or more hosts are interconnected, what we call a network, right? So similarly, IP address class A, B, C are divided into octet format. In class A, first octet is a network portion. Second octet is host portion. Second octet is host. Third octet and 4th octet. For class B, first 2 octets are network portions. 3rd octet and 4th octet is a host. For class C, first 3 octets, network, 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 and the last octet is a host portion. So now, if your requirement, your office requirement is if your office requirement is very large number of hosts, if host requirement is a very large number, if my host requirement is 600 hosts or 6,000 hosts or 60,000 hosts or like 6 lakhs, like very huge number of hosts your requirement, then we have to use which class? Class A. Example, if we take a railway department, so there will be like Indian Railways if we take, so very huge number of hosts are available actually. Entire the department, railway department is one. So we call entire railway department is one network, right? But in that, how many components, how many devices is there? How many hosts is there? Very large number of hosts. So they use class A addresses. Like if we take the best easy example is Geo network. So the network is one. Enter the India-wide, Geo is one network. But how many customers is there for Geo? Means how many hosts are available? Then which class IP address they have to use? Class A. So if it's a banking sector, like it's the largest bank in India, like SBI. So enter the SBI is one network. But in that, how many devices is there? Very huge number of devices in class A. So where your host requirement is a very large number, then class A is being recommended. Similarly, if we take example of home networks. At your home network, hardly maximum how many devices will be there, guys? By home networks, how many devices is there?
1 or
10.
1.
Okay, 5 to 8 devices, like your mobile phone, your laptop, and your family members. Like hardly 5 to 8 devices at your home, right? So means your host is very few hosts. So very less number of hosts your requirement, then which class IP address is recommended over in your home network? A or B or C?
Class C.
C.
Class C.
C.
Yeah. So this is what we have to understand first. Where your requirement, based upon your requirement, then we have to decide in the real time also which class IP address we have to use for your companies. Based upon host requirement or based upon network requirement also. Like very few networks in A, B, C, like this. Okay. Now, if my network requirement is I need a networks, I need 180 networks, 180 networks I required. Anyone can tell me which class do you recommend for
B.
180 networks? Class?
Class B.
Why not class A?
It won't support the range. Right?
Okay. If my requirement is a 250 networks, then
C.
Class D.
C.
class B, still class B, 255 also, Madhu.
No, D. I said D.
Class, how can you use the class D? You forget about class D and class E. So class D is a multicasting, class E is a research and development. Like for your communication purpose, we are making use only ABC. That's it. Okay.
Okay. Yeah.
Yeah. So here we know that class A, first octet is a network. But we don't exactly the number of networks, right? The number we don't know. In class B, we know first 2 octets is a network portion, but we don't know the number exactly, how many networks is there in B. So that we need to be calculated. We need to be find out now. Okay, guys. Yeah. First octet. I mean, each octet. How many number of network bits? How many bits is it for each octet?
8.
8 bits.
First octet 8
8.
bits. Second octet
8.
8.
third octet
8.
fourth octet
8.
8. Yes.
8.
Class A, number of network bits. I mean, total number of network bits in class A. 8.
2 to the power 7.
Class A, total number of host bits. Total host bits. 8 plus 8 plus
24.
8. 24.
24.
Yeah. Number of network bits in class B.
16.
16. Number of host bits in class B.
16.
Number of network bits in class C.
24.
24. Number of host bits in class
8.
C. 8.
8.
So clear, guys, everyone? Okay, now priority bits. Number of priority bits in class A.
1.
Number of priority bits in class B.
2.
Class C.
3.
3.
3. So first, let me discuss number of networks. How many number of networks? That formula is you can see here 2 power number of network bits minus
1.
priority bits. 2 power number of network bits minus priority bit is the same formula for class A, B, C, all classes, guys. Okay, so first let me start the calculation about class A. Class A, 2 power number of network bits, please. 2 power
8.
number of network bits, 8.
8 minus 1.
Minus priority bit is 1. 2
2
power
7.
8 minus 1, 7. 2 power 7. What is the value of 2 power 7?
28.
So we got exactly how many networks in available in class A now. So before we don't know, right? Like before, first octet is the network portion we know, right? But now exactly the number we know now. Like if your requirement is a up to 128, then you can use the class A. If more than 128 networks if you required, can you use class A? No. So 128 networks are available in class A. It's clear, guys? But all 128 networks are not usable also, Here, 2 networks are minus 2. So in class A, 126 networks only. This minus 3 in only class A, not in class B and class C. That's it. Only in class A. So why minus 2 here? Like class A range is 0.0.0.0, 1.0.0, like 2.0.0, like we have 127.0.0.0. So 0 to 127 is a class A range, right? So very first one, which is 0.0.0, this is not usable for your LAN and WAN. This is reserved. This is a, like all 4.3 billion IP addresses for identification 000, which we call, it's a global ID. Global identification, like all 4.3 billion IP addresses, will be identified by this ID, guys, 0000. So which is indicates 4.3 billion IP. This is just ID purpose, identification purpose only. That is not a usable address. It's a global identification purpose only. So similarly, 127.0.0.0, this is reserved for loopback. So this is we call loopback ID. So what is the use of loopback ID? Like every computer, like any communication device, every computer data transmission, how your data is being transmitting from one device to another device means with the help of the protocol called TCP/IP, Transmission Control Protocol over Internet Protocol. So this TCP/IP is working in your computer or not? Your TCP/IP stack is working in your computer or not? To check that, to check TCP/IP stack, we have loopback ID. Like how we can check TCP/IP is working or not means just open your command prompt and you can use ping. Ping is a service to check reachability. Then you can use 127.0.0.1, getting reply and 0% loss. So means in my device, TCP/IP is working good. So loopback IP purpose is what? To check TCP/IP stack. So why two IPs have been minused here? One for global ID and one more for what? Loopback ID. In between, all IP addresses we can use. So that is why generally class A range is 1 to 126. So actually range is what? 0 to 127. But 0 is a global ID, 127 is a loopback ID. So we can use 1 to 126 networks. Is it clear for everyone? About class A? Yes. Right, class B calculation, same formula, 2 power number of network bits minus priority bit, 2 power number of network bits for class B, please. Class B, 2
16.
power number of network bits are 16 minus priority bit minus 2. So what is the value of 2 power 14? So 2 power 16 minus 2, 2 power 14. So 2 power 14, how many addresses is here? Like 16384. So 16384 networks are available in class B. Like all networks are usable, no minus 2 here. So minus 2 is done in class A, global ID and loopback. Okay. For class C, 2 power number of network bits. 2 power number of network bits are 24 minus priority bit 3, 2 power 21. 2 power 21 networks are available in class C. So 2097152 networks is there in class C. So now we got all the networks in A, B, and class C. So the number also we know exactly. So if your requirement is a 126 networks, then you can use a class C, class A. If your requirement is more than 126, then class B, up to 16384 networks is available in class B. If more than that your requirement, then you can go as class C. So based upon your network's requirement, then you can go for A also, B also, or C also. Is it clear? Okay. Now let me continue with number of hosts. How many hosts are available? number of host. Same like a networks, like number of host bits, number of host bits, 2 power number of host bits. Here, base minus 2, not power minus 2, base minus 2 means 2 power number of host bits. After, you can do minus 2 actually. I'll tell you that. First, Class C example. Class C. Anyone can please give me answer? 2 power number of host bits in Class C.
2 to the power of minus 24.
2 power number of host bits in Class C.
Class C.
8.
8. 2 power 8.
2 power 3 minus 2.
Class C,
2
network,
power
network,
8.
network, host means first is 8 bits, right?
2 power
Yeah.
8 minus 2, 254.
2 power 8 base minus 2. So 2 power 8 value is what?
256.
256 minus 2. So what is 254 here?
54 host.
Number of hosts.
254 usable host, valid host per network. 54 valid host per each network in Class C. Okay. So actually we have 256, but 2 IPs are been minused. So then you can usable is 254 valid host per network. Let's see about Class B. Class B, same 2 power number of host bits. 2 power host bits are 16 base minus 2. 2 power 16 is what? 65,536 minus 2. So 65,534. 65,534 valid host per network. Now Class A. For Class A, 2 power 24. 2 power number of host bits in Class A. 2 power 24 base minus 2. So what is 2 power 24? 16 millions, like 616,777,216 minus 2. 16,777,214. Valid host. Valid host per network. So now we got to know all classes. We know Class A, how many number of networks and host bits and network bits and host bits in all classes, right? If a host requirement means in the home networks, how many IP address will be, how many devices will be there? Maybe 5 devices or 10 devices, right? Hardly. Then you can use Class C. Because of up to 254, you can use Class C. If it's at a small offices, small organization, if there are be 50 to 100 devices, then which class IP address recommended? Class C. So that is the reason mostly we are very familiar with 192.168 IP address, right? Why 192.168 is a Class C IP address. So we are till now connected to the small organizations or home networks. Like if you go for any IT companies, like large companies, then will be we used to work with the Class C IP addresses also, Class B IP addresses also. Okay. So this is all about number of networks in Class A, number of hosts in Class A and B and C. So clear for everyone? Any doubts? Yes, please. Any doubts?
Yes.
All right. Everyone, any doubts here?
In real scenario, we can use class B and class A.
Yes, A also, B also, C also, yes. If your requirement is more than 256 IP addresses, then you have to go for class B only now.
Okay.
So if your requirement is more than 65,000 IP addresses, you have to use class A. Yes, so if you use, of course, A, B, C.
Okay.
Yeah. Actually, I'm waiting for one question from you, but you're not asking that. You're not asking
For
why
D and E,
-2 here. Yeah, B and E.
like for that, how this range is calculated, like host, and is there any
No hosts,
calculation
no
for
no
that?
networks in D and E. Only ABC.
Okay.
In D, no networks. This is completely multicasting purpose now.
Mm-hmm.
So once our routing protocols is started, then you can come to know what is the multicast address where we use it. Okay. So for local,
Okay.
like LAN and WAN, only ABC.
Mm-hmm.
Yeah. The main question is here, in number of host calculation, for every network we are doing 2 IPs are being -2, -2, -2, -2. Why we are doing here -2?
One is broadcast and second is for default gateway.
50% correct. Huh? Okay. Okay, tell me number of networks calculation for class A, you done -2, right? Why -2 here in number of networks? In number of networks, only for class A, we done -2. Why -2? Two networks is -2. Why?
We won't use first
One is
network and
loopback
last
and
network.
We don't use
global
okay,
ID
but
one
One is
what
packet.
we call the
global ID.
networks? Yeah. One for global ID and one is what? Other one is what? Loopback ID, right?
Loopback, reserved for loopback.
So in number of networks in class A, why -2 means one for global ID and one more for what? Loopback ID. Now what about in number of hosts? Every network you're doing -2 here. In number of hosts, the formula itself is doing what? Number of host bits -2 means 2 IPs are been minused. Why two IPs are been minused here?
One is for the global ID and the other is for loopback ID. Those are getting minused.
That is done in class A. In number of networks, that is finished in class A only. So here we are doing the number of hosts. In number of hosts for every network there is a -2. That is my question. Yeah, let me explain.
Is it because of the 32 bits in the network?
No. 10 dot, I'm taking example of class A, 10 dot, 0 dot, 0 dot, 0 is IP address, right? What will be the next IP address? Next address, what will be? Next IP address is 10 dot, 0 dot, 0 dot, 1 or 10 dot, 1 dot, 0 dot, 0.
10.0.0.1.
But it could be 10.1.0.0.0. zeros. No?
The first one.
Okay, I will tell you clearly how it been. The pattern is, if you have purchased one brand new vehicle and your speedometer, like a meter reading is all zeros, and you have ride 5 kilometers, where number will be changed in the left side or right side?
Left side.
Right side will be
Sorry,
changed
right side.
5. So means 5 kilometers here, right? So what if number is changing the right left side? How many kilometers you ride? 50,000 kilometers, right? So that should not be like that, right? 5 kilometers means here. Okay, after 9 kilometers, 9 will be changed. After 10 kilometers, 10 will be changed. Like 20 kilometers, 30. After 90 to 99. So after 99, now next bit will be changed, right? So up to here, 9, 1, 2, 3, 9 here, first bit. After 9, second bit will be changed up to 99. After that, third bit will be changed up to 999. After that, fourth bit will be changed like this. So the direction is in this direction, right? Left to right most bits. Same like your IP addresses also. So 10 dot 0 dot 0 dot 1, 10 dot 0 dot 0 dot 2, like 10 dot 0 dot 0 dot 3 up to 10 dot 0 dot 0 dot 255. 1, 2, 3, 4, 5, like 255. Now what will the next IP address?
10.0.1.0.
So fourth means the first bit is done now. Next bit has to be changed, right? So 10.0.1.0. Yeah, 10.0.1.1, like 10.0.2.0, like 10.0.2.255, like 10.0.255.255. Now 10.1.0.0. So finally, we can write 10.255.255.255. So this is completely 10 dot network range. I mean, okay. After 10, 55, 55, 55, now 11 will be started. So 10.0.0.0.2, 10.255.255. How many total IP addresses is there? Don't count here like this. I mean, actually, how many IP addresses will be there? 16 million, which is 16,777,216, right? But we are doing -2. So why -2 here means the first one, which is 10.0.0, this is not a usable address. This is for identification of the network. We call it as a network ID. Network identification purpose, we use it. ID is what? Identification. What identification? The whole IP addresses comes under like 10.1, 10.2, 10.3. So these all IP addresses are being identified by, so the one ID which is 10.0.0.0. The last one is also not usable, which is 10.255, 255, 255. This IP address which we call broadcast ID. So here two IPs are being minused, one for network ID, one more for broadcast ID. Like network ID and broadcast ID in between of network ID and broadcast ID, all IP addresses we call it is usable addresses, or we can call valid IP address. So only valid IP addresses we can assign for your host. So we cannot make use network IDs or broadcast IDs. So this is two IPs are is common for every network. If you take a 11 dot network, yes, 12 dot network, 13 dot network, every network it is a common. Two IPs have been minused. For what? Network identification purpose and broadcast identification purpose. Okay, guys?
So the network identification purpose in between this 10 dot network, right? We use.
Yes. So example, I have an IP address which is 10.28.2.9. So this IP address is been identified by which net ID? What will the network ID of this IP address?
0.0.0.0.
Yes, 10.0.0.0 is identification for this IP address. Like 10.0.0.1 to 10.0 like 10.55, 55, 54. In between, all IP addresses are being identified by 10.0.0.0. It's the network ID. Clear? Right. Now I have IP address 186.2.9.2. Then what will be the network ID of this IP address? Tell me.
86.0.0.0.
So 186.0.0.0, it is not a network ID of this IP address. It's wrong. So now the task is what? How to identify network ID and how to identify broadcast ID. Okay. So before identifying network ID and broadcast ID, Prashant, can you please make your mic mute? Okay. So now, first thing, before identifying the network ID and broadcast ID, the first thing is, first you identify this IPs belongs to which class, Madhu? Which class it is?
B.
Class B. So for class B, network portion, host portion, tell me. First octet is network. Second
Second one
octet
is
is
network.
network. Third one
Network.
is what?
Host.
Fourth?
Host.
Host, right. Then how we can identify network ID and broadcast ID means in host portion. In host portion, if we make it is a zeros. Zeros in host portion is network ID. 255 in host portion is a broadcast ID.
Broadcast ID.
With respect of any classes. Class A, class B, class C. The whole complete host portion, if you make is a zeros, is a network ID. In the host portion, all 255s is a broadcast ID. Even if you cross-check with the class A example, the class A first octet is network, host, host, host. The
Host.
three
Yeah.
hosts, we made it as zeros, right? Is a network ID.
Yeah.
Same
Yeah,
like
yeah,
a,
got
in
it.
all three host portion here, 255 is a broadcast ID. Then now, what will the network ID of this IP address now? Tell me.
186.2.00.
Perfect. So 186.2.0.0 is network ID. And what will be the broadcast ID of this IP address?
186.2.55.255 is the broadcast ID.
Perfect. So 186.2.0.0 is a network identification, which is we call network ID. And 186.255.255 is broadcast ID. Then what we call in between all IP addresses?
Usable IDs.
Usable IP
Valid
addresses or valid IP addresses. Valid IP address. So can you anyone please tell me how many valid IP addresses in between will be there?
Huge amount, right?
Tell me the number.
Class B.
Okay.
65,534.
Perfect. Very good. So
65.
60, yeah, 65, 536 is actually, but we done -2 and we can have 34. So why -2?
Network ID and broadcast ID.
Very good. Network ID and broadcast ID. Like next example, so we have 192.168.25.2021. So please tell me the network ID and broadcast ID.
92.168.25.0 is the network ID. And 192.168.25.255 is the broadcast.
How? Explain it.
It is 192 is a class C IP. So class C, the first three networks are first three bits are the network bits, and only one bit will be the host bit.
Perfect. Very good.
21 is the host.
Yeah. So 192 is a class C range, class C IP address. For class
Yeah, in
C,
that scenario,
first three octets are
0 will be
network
the
and
network
last octet
ID,
is a
last
host.
and 255 will be the broadcast ID.
Yes. So 192.168.25.0 is a network ID, and 192.168.
Hello, Balu?
Yeah, please. Hello.
Hello.
Yes, can you hear me?
I think that.
Hello.
Yeah. Here.
Yeah. Okay. So 168.25.255
Balu,
is.
your voice is cracking. It is for me or for all?
It is clear.
Me, it's clear.
Network ID and broadcast ID. So in between all IP addresses, what we called valid IP addresses, right? How many valid IP addresses in between?
254.
154.
256 actually, minus 254.
Minus 2. Yeah.
Yeah. So now we got to know, like from yesterday onwards, we have started to discuss about IPv4 is 32-bit address, and we know how to convert from binary to decimal, decimal to binary, and the ranges of IPv4 address, like which is a starting IPv4 address and which is the highest combination in between all 4.3 billions and classified into 5 classes A, B, C, D, E, and what is the purpose of A, B, C, and D and E, and what is the ranges of class A, class B ranges and the calculations. And later on we have octet format, like class A, how many networks is it, class B, how many networks is it, like class C, and how many hosts is it, and what is the network identification, broadcast identification, and valid IP addresses. So it's all the logics we got it. So hope you everyone is following me, right? All of you. Any confusions here?
No, sir.
Very perfect. Good. And then you have a small task. Identifying valid IP addresses. So here you have the list of IP addresses. You try to identify the valid IP addresses. So first one, is it valid IP address? Yes or no? 119.1.1.1, is it valid IP address?
No.
Yes, it is valid IP address.
Why no? Yes, it's of course it's a valid, right? 119.1.1.1 is, yes, it's valid IP address.
It is valid.
Yeah. Second one, is it valid IP address?
72, 17.
Yes.
Yes, it is valid.
Yes, sir.
Valid.
Okay.
No.
I'm coming here, 172.17.2.9. Can you please find out this IPs belongs to which class?
Class B.
B.
Class
Class
B.
B. Okay. Can you please find out what is the network ID of this IP address?
172.17.000.
0.0.
Okay. Okay. Can you please tell me what is the broadcast ID of this IP address?
172.117.255.255.
So this is a network ID and it's a broadcast ID. So can we use network ID? No. Can we use
No.
broadcast ID? No. In
No.
between all IP address, what we called?
Valid IP
Valid
address.
IP address.
Same question I have you asked here. 172.17.255.255, is it valid IP address?
No.
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 But just before you say yes. Huh? That is what we need to understand here actually. So it is not valid IP address. Is a broadcast ID of class B broadcast ID? Answer is no. Next example, 11.1.0.0. Is it
No,
valid
this is
IP?
also
Valid.
No.
it is a network ID for
No, sir.
network
No.
ID for
Come
class
on,
A.
come on, come on. It's valid.
Yeah, valid.
11.0.0. is a network ID of class A, but my question is 11.1.0.0.
1.0.0.
Yeah,
If
correct.
it is a
Sorry.
second octet is also 0, then it's a network ID. But here 11.1. is a right, so it's a usable address.
A range 0 to
Okay. Fourth
Yeah.
one, 195.255.0.55. Is it valid IP address?
No.
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 No. Is a broadcast area of class C? Answer is no. Last example.
no.
Yes.
Why?
Network ID. It's network ID.
Network ID.
Class B.
Class B.
It's a class B network ID. So 142.10.00 is network ID of class. So we got to know about now all logics in IP address. So I hope everyone has a good knowledge on identification of network IDs, broadcast IDs, and usable addresses and classes, right?
Yes.
Okay.
I have a question.
Yeah, please.
When we talk about class A, we only talk about 10 series. Why not 7, 6, 5?
Yes, you can use it 7 also, 8 also. In my example, I'm taking this 10.
No,
You
but
can
in
take any other
the
example.
natural, but even in the natural phenomena in the current world also, wherever we talk about class A, we talk about 10 IP,
Okay,
10
okay.
series.
I'll tell you the logic why it is, Anand. I'll tell you. Wait for a few minutes and you can get answers. Okay?
Thank you.
Okay, right. Now, yeah, of course, it's a good question, Anand, actually. I'll tell you why it is. When you talk about class A, we used to talk about only 10, right? I'll tell you that logic why. Here we have two computers, PC1 and PC2. All of you, listen clearly. This is very, very important logic. Please understand. PC1 and PC2, two pieces are connected together. The first computer, like PCA and PCB. First computer, IP address 10.0.0.0. Can I use this address to assign computer? Can we use it?
No.
No. Why?
No, we cannot use.
Network ID.
It's a network ID. Okay, we cannot use it. Now, can I use 10.0.0.10?
Yes.
Yes.
Yes. Okay. So computer A 10.0.0.10 I have assigned. For computer B 10.128.2.19 have assigned. 2.19. So computer A IP address is 10.0.0.10. But computer B IP is what? 10.128.2.19. Now computer A and computer B, both PCs, will they communicate?
No.
Yeah, it should communicate.
Yes or no? No. Yes.
No.
Okay, next example, next case, 172.18.2.9 and computer B 172.19.2.8. Will they communicate? Here 2.9, here 2.8.
No, it will not communicate.
Okay. Next example, 192.168 9.2, 192.168 10.2. Will they communicate?
No.
Depends on the subnet.
Yeah, that is what we need to understand, guys. In your real time, your live environments, if from any one computer, if you're not able to communicate with other computer, generally what it can do, what is the troubleshooting you can do? We'll check the cables, we'll check these devices, you can restart your router, right? But technically, first thing is IP address we have to check. Like within a LAN, all users' devices should be in the same network. All computers should be in what? Same network addresses have to use, guys. So same network means what? How we can understand same network or different network?
Based on the
Example.
classes and
General example like 201, 202, 203, 204, 205. Like in your apartments, in your buildings, apartments, what is 204 indicates? What is 204 indicates, guys?
second floor, fourth floor.
So what is the 2 indicates here? Floors. What is 1, 2, 3, 4, 5 indicates?
Flats.
Rooms, right? Yeah, flats. Most similarly, floors is nothing but your network portion and rooms are host portion. Like to enable communication between all devices in the LAN, all devices should be in the same floor, I mean same network portion. Let me check. First case is a which class IP address?
Hey,
Class A.
Balu,
Yeah.
I didn't get you what you were saying.
Yeah, class A IP address is 10.0.0.0 for first computer, I mean computer A. I have assigned this IP address. For class B IP address is what? 10.128.2.19. Both PCs will they communicate, yes or no? These are scenarios we are discussing here in the first case, second case, third case.
Yeah.
So how we can understand it? Will they communicate or not means? So computer A, computer B, IP addresses both should be in same network. Then only they can communicate actually.
Yeah.
So how
Same.
we can understand the same network or different network? Then I use some example, the basic general example.
Mhm.
It's a class A, right? So class A,
Yeah.
tell me network portion.
Standard
First octet is network. Second octet,
Host.
host.
host. Third octet, host. Fourth octet.
Host.
Host.
What about computer B? Computer B also class A IP address. And first octet is network. Second
Network.
It is
octet is
also a
host,
Net.
host.
host.
Now, host A, host B, both computers to communicate, both PCs should be in the same network. Means first one is a which floor? 10th floor. I mean 10 dot network. Second computer is a which floor? 10th
Same
floor.
floor.
It's also same network. So here is a
Yeah.
10, here also is 10. Both are in same networks or different networks?
The same network.
So both
Same
are in the network portion is same. Then they can communicate actually. You forget, you don't bother about host portions. Here 128, here 0, no problem. Here 2, here 0, no problem. Here 19, here 10, no issues. Like you just focus on network portions. Your network portion is same or not? Yes.
Same.
The host portion can be any number. They can communicate actually. Okay?
Okay. Yeah, got you.
Yeah. Next thing is class B. Will they communicate? And
No.
second example,
No, these are the different network.
I'll explain. Class B, first octet is network, second octet
Is
network,
network.
third octet is host,
Host.
fourth one is
Host.
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 Computer B also network, network,
Host.
Host.
host,
Host.
host. So computer for computer A, first two octets, 172.18 is the network portion. It is in 172.18th floor, right? And your neighbor PC 172.19. It's a
So different
18th
network.
floor, it's a 19th. Like both are different networks or different same networks?
Different networks.
Different networks.
Different networks portion. Network portion has been changed here. 172.18, 172.19. Both are in different networks. They don't communicate. Yes. So first case is okay. Second case is not. No communication. The last example, will they communicate?
No.
Yes.
No, it is a class C.
It's a class C, first octet N, H. Here, network portion, network portion, network portion, and host. So 192, 168, 9. Here 192, 168, 10. It's a 9 here, it's a 10 here. Both are in same or different networks?
Different networks.
Different. They don't communicate. We'll do one thing. Let me change. Third octet is a 9. Now will they communicate?
Same IP, it will not communicate.
Again, no. IP address conflict will come. IP conflict.
Oh, yeah. Host
So,
is same.
yeah, can you repeat one more 202 in the same floor? No, it's not possible, right? So network
Yeah.
portion should be same. Host portion should be unique.
Yeah.
The host portion you can just change 21 or 22 or 23, any number, 202, something, right? So these logics we need to be understand real time very clearly. If your company is using class A addresses, then for all computers, like all devices in your network, first octet should be same for all computers if you are using class A addresses. If your company using class B addresses for all devices, first two octets should be same, then they can communicate. Hello. Yes. If your company is using class A addresses, then first three octets should be same for all devices. And a fourth octet should be unique number. So these logics we need to be keep in mind, guys. So when you're doing the troubleshooting, so when you're checking the IP addresses, you check with your computer and your server. Your computer and your printer both are in same network position or different network position. Okay. It's clear. And next example, computer 1, 127.1.1.1. For computer B, 127.2.1.9. Will they communicate?
No.
Back IP.
27 we should not use.
Very good answer. Perfect, perfect, guys. Appreciate you. So 127, how we can use it? Is it completely reserved for loopback, right? So we cannot make use it. So even if you try to assign
Okay.
Let me try to use this 127 IP address. Like right click on your Ethernet adapters, you can go to properties and click on IPv4 properties. Use the following IP address 127. We got error. IP addresses starting with 127 are not valid because they are reserved for what? Loopback addresses. Please specify some other valid value between 1 and 223. So we cannot use 127. Can we use 224?
No.
No, class D. So even 224 if we use, error. 224 is not valid entry. So up to 223 only because of class C maximum is 223. Can we use 000?
No.
Global ID. If we use 0 dot, error. Okay. Yeah. So same
Balu, I
makes
have a
sense.
question.
Yes, please.
So in that previous example, you told me only if suppose like if you take the 10 acted, so 10.0.0.0 is network ID and 10.255.255.255 is the broadcast ID you said. But now you said you cannot use 127.
127 is a loopback.
The whole thing is loopback.
Yes, the whole 127 is a loopback.
Then how there will be like more than millions of IPs, like if you completely aborted the 127
Of
whole
course,
IP
yes.
address.
That is why IPv4 is not designed properly. The whole 16 million IPs are being wasted actually here.
Yeah.
Yeah. Okay. Right. Sorry. Two computers here. Computer A and computer B. Now computer A IP address is 10.0.0.10. Computer B IP address is 10.0.0.0.20. Second case, 172.16.2.9, 172.17.2.8. Next case, 192.168.2.10, 192.168.2.10. First case answer, please. Will they communicate?
Yes.
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 Second case?
No,
No.
No.
Third case?
No.
Yes.
No, no,
Third
no,
case,
no,
no.
no, no. Same IP.
Third case, no.
no, sir. No, sir.
Oh.
Okay. So how we can say first case, both computer A, computer B, will they communicate? How we can say that?
Because both on the same network.
How we can say both on the same network?
Because
both
both
portions
IPs
are
are
same.
class A IP.
Both are class A. So first
Yeah.
octet is a network portion class A, right?
Network.
Yeah.
Yeah.
As a user, we know 10, 0 to 127 IPs are class A. So for class A, first octet is network, host, host, host. This logic we know as a users, right? But how computers know about this logic? This is very, very important question.
Priority bits.
How computers can understand it? So how your PCA knows about first octet is the network portion and remaining octet is the host portion, how your device can come to know it? Not only your computer, your mobile phone, your laptop, your servers, your routers, like all devices in your real world, like how the machines can come to know. So which is a host network portion, which is a host portion. On my PC and my neighbor PC, both are in the same network portion, a different network portion. We can communicate or we not communicate. So how these logics your devices can come to know.
Based on the subnet.
Right, Shiva? Shivateja?
Broadcast.
So we need to be conveyed to your computers. So computer class A, first octet is network, host, host, host. So whatever we know the logic, the same logic we need to tell to your computer. So we know class A first octet is network remaining host, right? The same logic we need to tell to computer, guys. Like how we can tell to devices is bits are 0s and 1. 0 or 1. 1 indicates networks, 0 indicates host. First octet 8 bits, second octet 8 bits, third octet 8 bits, fourth octet 8 bits. What is n indicates?
1.
Ones, right? Means how many ones here? 8 ones. Host indicates what? Zeros. Means how many
8 zeros.
zeros?
8 zeros.
Third octet,
8 zeros.
fourth octet.
8 zeros.
This is a binary language or decimal language?
Binary language.
Binary.
Convert into decimal. 128, 64, 32, 16, 8, 4, 2, 1. If you total it, what is the value?
255.
255.
Dot,
0.
dot.
0.
So this we called subnet mask. So what is the use of subnet mask? So your subnet mask is going to differentiate network portion and host portion. So if we assign 255.00 for your computer, now only your computer can understand first octet is a network portion because of 255 indicates what? Network portion, right?
Network portion.
Now by assigning subnet mask, by seeing the 0 here, now your computer can understand what is the second octet? Second octet is a host because of 0. Here 0 host, 0 host. So subnet mask is used to differentiate network portion and host portion. So this is a subnet mask of example of class A. Now you tell me guys, for class B subnet mask, what will be the class B?
55255.
255 255.
Perfect.
255 dot
So 255.255.0.0, because we know as a user we know NNHH. Then how we can convey this information to computer like this 255 255.0.0. So this is understand by computers. This is for user. Okay. Now what about class C?
255.255.0.
Perfect. So 255.255.255.0 is a subnet mask of class C. So based upon subnet mask, devices can understand where the network portion, where is the host portion. Okay. See, now back to your previous examples. First one is a class A, right? So what is a class A subnet mask? 255.0.0.0. 255.0.0.
0.0.
After assigning of subnet mask, then your PC can understand by seeing the subnet mask. 255 indicates what, guys? Network. Now your PC can understand my first octet is the network portion, means I am a 10 dot network. Your PC can understand it because of 255. Now your machine can understand first octet is what? Network portion.
Network.
What about second octet?
Host.
How?
Address
Zero,
class A.
zero, zero, right? Yeah. So it's a host, is a host, is a host. Now your neighbor computer, so by seeing the 255, your PCB also can understand this is my first octet, so it's a network portion because of 255. Network, host, host, host. Now both can understand PCA and PCB. I am a 10 dot network. Yes, I am also 10 dot network. You know, now we are both are the same network. We can communicate. So this is the logic behind our IP addresses. The logic is based upon what? Subnet mask. Okay, guys. Now for class B example. So class B, subnet mask please
255.255.0.0.
Yeah,
255.0.
yeah. Now, what your PCA can understand after assigning 255, 255.0.0? First octet is network portion. Second octet is what? Network portion because of 255, 255. So it's 172.16 is the network portion. And a neighbor PC 255, 255 here, but is a 172.17, right? So we are in a different networks, we don't communicate. Similarly, third example, like class C subnet mask is 255.255.255.0. So 255.255.255.0. Am I right? So what your PC can understand, first octet is network, 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 host because of 0. Here also network, 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 host. So I am 192. Yeah, I am also 192. I am 168. Yes, I am 168. I am 2. Yes, I am 2. Yes, guys, we are both are in same network. And host portion, I am a 10. I am also 10. Oh my God, conflict. Both are same host portion, right? So conflict will come IP address conflict. So based upon the subnet mask, your machines can understand host portion and network portion. Okay. So subnet mask differentiate network and host portions of an IP address, represented with all ones in the network portion and with all zeros in the host portion. For the second point, represent all ones in network portion, represent all zeros in host portion. The second point. And examples, class A, class B, and class C. Okay. So these are the logics in IPv4 address. Next point is, anyone can please tell me One IP address from Class A example. Class A IP address, please. An example.
Hundred dot 10 dot 250 dot
10 dot
10.
250 dot
25 dot 15.
25.15. Okay. Class C example.
Class C.
Yeah.
200 dot
200 dot
25 230
25 230 1. Okay.
Why we
From
can't take the
here,
235?
yes, of course you can take. But generally, people will say, if I ask the Class C example, what people will say generally?
192.
192, 168, 1.1.
172.
Yeah, Class B 172, like Class A 10 dot 0 dot 0 dot 1. You before asked me, Daniel, right? Why if we talk about Class A, why dot 10 dot, right? Yeah, that is what I'm explaining here.
No, 10. Why we use 10, but like
Yeah.
it is a range from 0 to 127, right? So in between, I can use anything, right?
Yes. So what is the range of Class A? Class A range is 0 to 127, and 0 is global ID, 127 is loopback ID. Let me take 1 to 126.
126.
Yeah. Class B range,
128 to 191.
Class C range,
192 to 223.
then in Class A, 1.1.1 is a Class A example, 2 dot is a Class A example, 8 dot is a Class A example, like 20, 30, these all are Class A examples. Then why people will say always 10 dot? Even a Class A also, 193 is Class A example, 194, like 200, 20 is all the Class A examples. Then why people will say 192 is? In IPv4 we have private IP addresses and public IP addresses. So what is the private IP address and what is the public IP address? The name itself is telling private IPs are used in private networks. And what is private network? Within a LAN, within an organization is private network. And what is the public network? So public IPs are used in public network. So public network is what? Internet. Private IP addresses are used public IP addresses used on internet. Private IP address used within the organization. Example, within a LAN, within an organization, right? It should be unique over the internet. Which one? Public IP. Similarly, private IPs also, it should be unique within the LAN or within the organization. But public IPs are being assigned by internet service provider. So we need to be purchased from internet service provider is public IP. We need to pay for it. If you need a public IP, then you have to ask to service provider. Service providers only can assign because of the registered IP addresses. Private IP address assigned by network administrator is a free. Then which IPs are private IP address, which are the public IP address? So actually class A range is 1 to 126. So every class we have private IP and public IP. In class A we have public IP, private IP. In class B also we have public and private. Class A also. In class A, IP starting with 10 dot 0 dot 0 dot 0 to 10 dot 255 dot 255 dot 255. A completely 10 dot network range is private IP addresses. Remaining all IP addresses are public IP addresses from class A. Remaining all IP addresses. So which is 1 to 126, which is 10 dot network. Completely the whole 10 dot network is reserved for private IP addresses. Remaining all are public IP from class A. Now similarly in class B, 172.16.0.0. So actually class B, 128 to 191 is the range, right? From this range, so starting with 172.16.0.0 to 172.31.255.255 is class B private IP address range. Okay. Now class C, 192, the whole 192.168.0.0 network to 192.168.255.255 is private IP address range. Other than private IP addresses, all are public IP addresses. So these private IP addresses we have to use within your LAN, within organization. So that is why we are very familiar with 192.168. That is why we are familiar with 10 dot network. Okay. When you're using a internet, a public network, then public IP address will come in the picture. Is it clear, everyone?
Yeah.
All right. So let me ask the quick questions here. The first one is 112.23.14.3. Which class IP address?
Class A.
Class A. What will be the network ID of this IP address?
Network ID 112.0.0.0.
What will be the broadcast ID of this IP address?
112.255.255.255.
What will be the subnet mask of this IP address?
255.0.0.0.
Is IP address is a public IP or private IP?
This public.
Perfect. One 172.19.25.2. Which class IP address?
Class B.
Network ID.
172.19.00.
Broadcast ID.
172.255.250.
Subnet mask.
255.255.00.
0.0.
Is it private IP or public IP?
Private.
Private IP.
It is private.
Private, yes. One 192.169.2.3. Which class IP address?
Class B. C.
Network ID.
192.169.2.0.
2.0.
Broadcast.
192.169.2.255.
2.255.
Subnet mask.
255.255.2.0.
0.
Is private IP or public IP?
Public.
It is public IP.
That's public IP. So it's all the logics we need to understand in the real time, guys. By seeing the IP address, these all the parameters will come in the picture, it will come in the mind. If you have any IP address, oh, this is IP address is so-and-so class, so-and-so network ID, so-and-so subnet mask, so-and-so broadcast ID, and is a public IP, is a private IP, is it usable or not, is a network ID or is a broadcast ID. These all the logics will have to come in your mind, guys. Okay. I hope everyone we got a clear logics on IPv4 address. So still, if you have any doubts, you can ask me now.
So what is the subnet mask of like 255, 255, 255, 255? Is that's the last one, right?
No, no, no. A subnet mask will only have class A, class B, class C. That's it.
Okay, so there is no subnet mask for class D and E.
No, class D multicast, class E is research and development. That is not used for LAN and WAN, right?
Yep.
Yeah, only ABC classes.
Gotcha.
Any more doubts?
So for a public IP address, is that provided by the ISP?
Yes. Public IP addresses need to purchase from internet service provider assigned by internet service provider.
Okay, that's all purchased right there.
Yeah, if you need a public IP for your company, you have to ask your local service provider. They can provide you the public IP to reach your company traffic to reach internet through public IP address.
Okay, and that's more expensive, obviously.
Yeah.
Okay.
Yes.
Balu, that means that now whatever this act or whatever the other internet service providers are using the IP address, so they will pay and they will use.
Yeah, of course. You have to pay. All public IP addresses which is provided by IANA to service providers. So from service providers, customer will be purchased. Service providers will purchase from IANA. IANA is the head. Internet Assigned Numbers Authority. From IANA, they'll get to service provider to customer.
Internet? What is that? Internet?
Internet Assigned Numbers Authority. All right, guys. So it's all about for today. And tomorrow.